As a continuation, our business analytics or applications of regression analysis in business analytics, we are learning econometric analysis, popularly known as regression analysis. The data set we'll use today is here. The characteristics of the data says that this is a cross-sectional data. What is cross-sectional data? Cross-sectional data means that data that will be collected from many observations on a point in time, 1990 only, and many dimensions. So here the data is for 1990. We have collected the data about different firms. These are the firms and the firm's sales, the firm's return on equity, the firm's return on total stock, and this salary. Say for example, this salary is the CEO salary, CEO's Chief Executive Officer's salary. And if the officer is working in a industrial firm, manufacturing firm, if the CEO is working in a financial firm, so these are the variables. That means if the CEO is working in an industrial firm, then we have used 1. And he cannot work in a financial firm, consumer product firm, or transport firm. All are 0. These variables are known as the binary variables. These variables are known as the binary variables. In our previous case, we know about the definition of dependent and independent variables, or dependent and control variables. Here, one more variable is added, that is binary variable. Binary variables are mutually exclusive. Mutually exclusive means that when you are working in a manufacturing firm, industrial firm, you cannot work in a financial firm, you cannot work in a consumer product firm, you cannot work in a transport or utility firm. So these variables are mutually exclusive. One means you are working in that company. Say for example, first few CEOs are working in industrial firm. This second,
Wow.
yes.
Why do you use these variables? Because we can sort those data that these people works in farm, these people works in product farm, these people work in utilities. If it is mutually exclusive, so why do we do this binary variables?
Binary variables, good. So we are learning inferential statistics. We are going to make inferences on the population. These are the sample taken. All right. And when we have collected the samples, then we went to manufacturing firm, we went to financial firm, we went to consumer product firm, we went to transport firms. So when we are going to a industrial firm, we say that others are 0. When we went to a financial firm, we say others are 0. When we went to this one is consumer product firm, others are Zero. Are you getting? Now, why I am using? I am making an inference. Our research question is what are the determinants of CEO salary in Bangladesh. Say for example, this is our research question. When we set the research question, what are the determinants of CEO salary in Bangladesh? So CEO salary is the this is CEO salary ultimately. This is CEO 1999 CEO salary. CEO salary. So this is the dependent variable in our today's analysis. And all are independent variables. Say for example, the coefficients of industry will say whether whether if he is working in a industrial firm, then whether there is any impact on the CEO salary or not. When he is working in financial company, whether there is any impact on CEO salary. Whether he is working in a utility company or consumer product company, what is the impact? Are you getting? Because the CEO are available in all types of companies. We are now going to determine whether the CEO of financial firm are getting more salary than consumer firm or transport firm. And our research question is, what are the determinants of CEO salary? All right, have you got it?
Yes, sir.
And the another feature is that here, if you check the data, this is 918, this is minus 35. This the figure sales figure is 29,799. But all other than these two big figures, all other figures are small, isn't it? Small. Is it? To make the data comparative, to make the data comparative, we convert this big figure into a small figures by using natural logarithm, log salary. So it was 1,261. Now it becomes comparative. It was 5,025. Now converted into 8. And how did we do that? By using just natural logarithm. There is a n log system, natural logarithm or log, just taking the log value. All right, log value, log value of this figure, log. But here log we use a natural logarithm. All right, normal log and natural logarithm is little bit different. That's why the figure you can use natural only log. In that case, you will not say it is natural. You will say log of salary, log of sales. You can use, no problem. All right. Natural logarithm in Excel ultimately another formula. Okay, maybe you know it because you 90% of my students are science background. That's why I'm not going to discuss those issues in details. For the moment, the data is clear and research question is clear, isn't it? Research question is, what are the determinants of CEO salary in Bangladesh or in America or somewhere else? And these are the primary data. We assume that these have been collected from the different firms: industrial firm, financial firm, consumer product firm, and transport firm. Now we are going to quantify the relationship. And we'll quantify the relationship using SPSS, isn't it? So as we are going to know SPSS, we are going to know how to operate SPSS or very beginner session. In future, maybe we think of advanced applications of SPSS, but for today, the screen is visible, is it?
Yes, sir, visible.
Okay. So we are on the SPSS software. Maybe you can get this software from me later. But for today, I'm opening SPSS because we know how to do it in Excel, and we will do it in SPSS. How we can do it in SPSS? We open the SPSS file. These are open a new file. All right. This is a new file. What we will do, we will copy and paste from Excel, and we will copy only the variables, only the variable, not the observation number or the variable names, or only the variables. 200 night observations are here. We are just copying this figure to a new data set here. Have you got it?
Yes,
This
sir.
is how you will get the data in SPSS. After getting the data, you will run the regression, but for running the regression, you need to know the names of the variables. You can rename the variables here. Here, number one variable is CEO salary, isn't it?
Yes, sir.
Number number. Oh, that means you cannot use a space. CEO salary. CEO salary. Then number two variable. Number two variable is, and this is also coding system. We will use code in Excel. And there is another chapter in our research methodology book, coding variables. So you are getting the idea. Coding means short, giving a short name. Salary, we use the word CEO salary because we are going to determine the impact of different factors on the CEO salary, and percentage change in salary. SALARY, percentage change in salary. Then next one is sales. Next one is
Sales. Then
ROE,
equity.
return on
Uh,
equity. Next one is changes, percentage changes in ROE, record. Then next one is return on stock. Return on stock. Then percentage changes in stock now. Then return on stock, percentage, industry. If the CEO is working in manufacturing company, industry, INDUS, industry. If the CEO is working in financial companies, banks, FINANC, financial companies. If the CEO is working in consumer production or FMCG, fast moving consumer firms, FMCG, or if the consumer production, and then if the CEO is working in transport or utility companies, utility. We use the code UTI light utility. Then we use the log salary, log SALARY, log salary, then log sales. L cells, log cells. So these are the data, and the name of the variables have changed now, isn't it? So is it clear up to this point? Loading data is clear?
Yes, sir. Clear.
Okay. Now, how we can analyze the or calculate the regression coefficients? As in our Excel sheet, we'll use here analyze. All right. Analyze, then we'll go to regression, and this is linear regression analysis. Linear regression. Then we will choose the dependent and independent variables. Which one is dependent variable here?
স্যার সিও স্যালারি বাদে সবই হচ্ছে
C,
ডিপেন্ডেন্ট, সবই
C
ইন্ডিপেন্ডেন্ট স্যার, সিও স্যালারি বাদে
independent. Good.
সবই
See, we will use CO salary as the dependent variable, and when we will use the CO salary, we cannot use the log salary. We cannot use the log values. While you are using the normal values, we cannot use the log values. So for example, when we use sales, we will not use log sales. So sales, return on equity, return on stock percentage changes will not affect the relationship. Whether he is working in industry, financial companies, consumer production company, utility or transport company, these are the dependent variables. All right. Just press OK, you will get the results. This is the results. This is the results, and R square is only 8%. That means only 8% data is explained by the relationship. The relationship that we are showing here in our coefficients, this relationship is explained only by 8% data. That means we have to think alternatively. We have to increase the R. Maybe there are some problems. The problem is that maybe the values are not linear. Say for example, there are some big figures and the coefficients are very absurd. 995 is constant, and these are the coefficients. 668 is the consumer product coefficient. And also significance is also 1%. This is good, but others are more than 5%. More than 5%. So what we will do, we can try with more linearized way. How we can make the data more linearized? By converting CO salary, these two big figures, into a small figures, log salary and log sales. We can have a new calculation using log salaries and log sales. So here we'll not use salary, we will use log salary as the dependent variable, and in independent variables we will replace sales with log sales, because these are the two big figures we have converted into small figures. So these are the variables. Now we will run the equation again, and the results this time, the R is much better. It was 8%, now it is 35%, R square. So there is a good relationship. More than 30% is acceptable, more than 50% is good, and more than 75% is better. So, and the coefficients here, the coefficients constant is 4. If the company's return on equity is higher, then the salary of the CEO will be 0.01 times more. When return on stock, this is a little bit not good figure, very insignificant. Return on stock, the impact of return on stock is insignificant. Then if the CEO is working in a financial company, then his salary will be 0.158 compared to working in other industries. When the CEO is working in a consumer production company, his CO coefficient will be 1.184. When he's working in a utility company, his relationship with salary is negative. And the company sales, when sales has 25% coefficient, that means if the sales of the company is $1 more, then $25 0.25 cents or 25 cents will be the company's CEO's salary. These are the factors and standard errors. Compared to the previous case, the standard errors were huge. Now the standard errors are very low. So we can say that with log salary and log sales, the relationship becomes linear and more predictive power. The model has more predictive power, and level of significance is also all very good. So this is how you are going to explain the relationship. And then if I say that what are the determinants of company's CEO salary? The determinants are if the return on equity is good of a company, the salary of that company's CEO is good, and the relationship is 0.01. And R is also good, 35%, and standard error is very low, and significance is also, it is 99% level of confidence or 1% significance. And there is no relationship between the return on stock and the company's CEO salary. The significance is 9.2, so you cannot say this is a predictor. Then finance, if he is working in a finance company, it is also 10% level of within 10%, 90% level of confidence. This is also beta coefficient is 1.58. Positive relationship, and utility has negative relationship. So when you will explain the salary of a finance company, you will only take care of this figure. You will not take care of these two figures. And because of collinearity problem is that there are some correlation with the other variables. That's why this variable is excluded from the analysis. Industry coefficient is not given here. So to know the industry coefficients, what you have to do, maybe you have to omit first finance, then consumer production, then utility, and then you can know what is the relationship between the CEO of industry and his salary. So this is how you can use your SPSS for business analytics. So it is just how to open and how to use SPSS for econometric analysis or regression analysis or answering the research question, what are the determinants? And you know how you'll write the results, because in your presentation, you made the matter how you'll write in your research paper and how you'll write the equation. This has already been presented before you. Just today, we have applied the data in a software platform, and the name of the software is SPSS, Statistical Package for Social Sciences. So this is how you can use your data in SPSS platform. And SPSS platform is same as Microsoft Excel. You can also save the file here. You can copy and paste in Word. It is compatible with Excel. You can copy Excel data and paste here in your data view. You can save the data in a similar way, and the save will be SPV. This is result saving, and you can save the data also. So when you are going to save the data, you can also use this data we are using. So you can save the data in the similar manner. You can save the data. And the data format in SPSS is SAV. You can, if you save the data, next time when you will open the data, you do not need to change the name of the variables. This is the basic application of econometrics in SPSS. More explanations. Say, for an example, what is the impact of multi-collinearity problem? What is heterodiscity problem? This robustness of the model, we'll discuss it later. And if we recall the variables or data characteristics in today's analysis, you maybe know the definition of binary variable. What is binary variable? A binary variable is a variable that can only take on one of two possible values, often represented as 0 or 1, true or false. But in statistics, you cannot write true, false. So you have to use 0 or 1. Yes, no means 1, 0. Or this is also known as categorical variable. Categorical variable also means qualitative variable. Qualitative variable. An examples: male, female, yes, no in a question, true, false in a statement, pass, fail in a course, success, failure in a program. And the nickname of this binary variable is that the binary variable is also known as a dichotomous variable. Another term for binary variable. It is also known as categorical variable. Binary variables are a type of categorical variable. Binary variable, when you use in regression analysis, is also known as a dummy variable. Why it is known as dummy? Say, for example, when you use 0, it indicates that this CEO is not working in a financial service company. So CEO is not working in a financial company, and its representation is 0. So this 0 is ultimately dummy, or 0 indicates not working in a financial company. So when you are using binary variable in regression analysis, this is also known as dummy variable. This is also known as dummy variable. Variable. And the data characteristics in our model today is cross-sectional data. What is the characteristics of today's data? Is cross-sectional data. And cross-sectional data means observations of many different individuals at a given time. Say for example here, our data is about 209 companies, 209 individuals. That is known as individuals. 209 companies, and the data was taken in 1990. Single period of time. Single period of time, 1990. Maybe you can say 89 is here. 89, 90 means that when you are going to calculate the percentage changes in 1990, you need to know about the figure in 1989. Otherwise, you cannot calculate the change. So this is not the 1980 data. This is ultimately 1990 data, percentage change. Yes, Richie.
স্যার আমাদের পার্সেন্টেজ চেঞ্জটা কি দরকার হয়েছে অ্যানালাইসিসে, মানে আমি
No,
কি
no,
যতদূর জানি দরকার হয়?
we didn't apply percentage change here today.
তাহলে স্যার এখানে দেওয়া হয়েছে কেন?
Only as we have the data, when you will collect the data, you will collect many more data. Say for example, company's name, how many years the company is operating, etc. All the data will not be important to answer your research question. Maybe you can use it in another research. All right. Maybe
জি
what is the impact of percent salary changes and percent change in ROE in determining uh, executive or CEO's salary? All right. So for the moment, we didn't use all the variables. The percentage change ultimately doesn't make any sense to answer the research question. What are the determinants of CEO salary? That's why we haven't used these two change variables. We use in today's analysis the cross-sectional data. Why the data is cross-section? It is taken for a single period of time and many individuals mean many companies, 209 companies, and there are many dimensions of the data. These are also known as the dimensions of the data. So this type of data is collected about individuals. Here forms are the individuals. Over a single period of time, over various points in time. It may be various points in time where no special attention is paid to that time element. For the moment, you don't need this point. So only single period of time. Data can be collected using sampling a process or from historical data sources. So this data is collected using sampling technique. All right. And when you are collecting from the historical records, this will be your secondary data. When you are collecting from sampling base by observation, this will be your primary data. What is cross-sectional data is clear. Then
Yes,
time
sir.
series data. Time series data means that a time series is a data set that tracks a sample over time. Say for example, sample stock price from 1990 to 2024. So a time series, is there, and sample, one sample. In particular, a time series allows one to see what factors influence certain variables from period to period. So in 2015, the price of the stock was 56. What are the changes in 2016? Difference is $1, $1 increase. So many points of time and one variable. This is known as time series data. This is known as time series data. And the time series, it should be a series. It cannot be 2015, 2018, 2030. This is not a series. So you have to organize in a time sequence. That is time series, time and the value of the variable of study. This type of data is explicitly organized in time sequence, generally equally spaced units such as days, equally spaced. 1 year here, the space is 1 year. It may be days, weeks, months, quarters, years. Here data are presented for a single individual in time sequence order with one row of data for each year. One row of data for each year, one row. Each row consists of the characteristics under study for that year. This is the characteristics of the study stock price of a company. The data may be panel data or longitudinal data. A panel data contains observations on a number of units belonging to different clusters over time. That means the characteristics of cross-sectional data and characteristics of time series data are combining together to develop panel data. In cross-sectional data, only 1 year data was summarized. Here, many years data will be summarized. In uh, uh, time series data, you are using series of time. Here, you will use series of time and many characteristics. So a panel data set contains observations on a number of units belong to different clusters. A simple example of panel data is the value of the gross annual income for each of 1,000 households in New York City. 200 forms from 5 boroughs collected for each of 10 years from 1991 to, so you have time series 91 to 2000, and many individuals, 1,000 households, many boroughs, 5 boroughs, many boroughs. All right. So all these boroughs are the clusters or panels. And the example, say for an example, these were the time series data, isn't it? 15. The stock price was 56, 2016, 57. This is the time series data. This is ultimately time series data. Now you are adding more dimensions, profit. You are adding number of employees. You are adding male or female, dummy variable. You are adding age. This is dummy variable, or this is also known as binary variable. So these are the features of cross-sectional data. One year, 2020, 15, these are the features. So here we are combining time series data and cross-sectional figures for many individuals together. This is known as panel data, or this is known as longitudinal data. And this data ultimately is very popular in econometric analysis, because you have to analyze, you have to make inferences on the population. So it may be based on many years data, many different characteristics, many observations. This is known as panel data. Panel data. Then and applications in SPSS, we applied factors. Our today's research question was determinants. What are the determinants or factors affecting CEO salary, isn't it? What is our research question today? Factors affecting What are the determinants of CEO salary? CEO salary. And we have applied the data in SPSS. Maybe you have got the idea how to open, save, and close the SPSS, how to calculate the econometric results. More explanations, more tests, more coefficients we will discuss in our class and also in future, because we are learning research methodology and how you will write as a research paper. You will summarize these results. You will just get the results from this analysis, and then you will summarize in separate. First you will write introduction. There you will explain the objectives and research questions. Then you will do some literature review. Then you will write the methodology, and methodology, how you will write the methodology and equation. Equation is not written here, but you have to write how to write the equation. Then you will explain the sources of data in your methodology. Then you will find the results, and then you will describe the results or discuss the results. Finally, you will conclude. These are the steps in your research process. So if you have any questions, we can deal with your questions. Do you have any questions, Mr. Osama? Mr. Osama,
Yes,
are you here? So is it
yes, sir.
clear how you will use Excel data in SPSS?
Yes, sir. It's clear for me.
Okay, thanks. So, anything else? So today, if we sum up today's lecture, what we have learned today, we have learned the characteristics of data. The data may be time series data, the data may be cross-section data, the data may be panel data. So in our example today, we have used cross-section data. And we have learned about the different variables. The variables are, number one is dependent variable and number two is independent variable or independent variables. And you know about the dependent and independent variables. And independent variables are also known as control variables. And one of the independent variables we have discussed today is dummy variables or dichotomous variables, or we use the binary term, binary variable, because 0, 1 is taking. So binary variable,
What is dichotomous variable?
dichotomous variable, and binary variable is same, nicknames. All right,
Yes, sir.
good.
Thank you.
Question is very important. 0, 1, another term for binary variable, and dummy variable and binary variable, and this is ultimately categorical or qualitative variable. Categorical or qualitative variable we can use. So this new variable is added today, binary variable, and dependent and independent variables we have explained, and we have also learned about cross-sectional time series and panel data. So if you do not have any questions, then we can wrap up for today. Maybe you have got some idea how you will use SPSS. Miss Afrin, are you here? Miss Afrin. No. That means this is the problem of online class. After joining the class, especially students do not listen to the speakers. Is this Sharno? Is it Sharno? Also, she is not here. How can I? But how can I make sure that you are listening to me, Mr. Alex?
Sir, I am present, sir, but I have mic issues, sir.
So, can you please tell me what is dichotomous variable? What is dichotomous variable? Or can you tell me what is, dummy variable? Mr. Sharno. Mr. Alex, can you hear me? Alex is not here. Mr. Swad,
Yes, sir.
so can you tell me what is binary variable?
Sir, binary variable is a variable which indicates true or false. In statistics, we cannot tell true or false, so we use 0 or 1.
Good. So, and Mr. Alex is absent. Maybe as only one class, that's why I'm not taking action, online class. We can make him absent. Still, we have the power, isn't it? Miss Julie, do you have any question?
স্যার আপাতত কোশ্চেন নেই, আবার যখন প্র্যাকটিস করব কোশ্চেন থাকলে জানাবো ইনশাল্লাহ।
And Mr. Fahim?
Yes, sir.
So, is it clear how you will open and use econometrics or regression analysis in SPSS platform?
Yes, sir.
So, if you still have any problem, the lecture is recorded. We'll give you the link of the records. All right.
Thank
So
you so
thank you
much, sir.
very much for joining the class. We are ending today's session. See you after Eid.
আসসালামু
So,
আলাইকুম স্যার।
ওয়ালাইকুম স্যার, ঈদ মোবারক
yeah,
স্যার।
Eid Mubarak to all of you.